This video is part of a series where I take you through every single option in Betaflight 4.3 to teach you what they do and how to set them up. If you're here for the receiver tab, that's what this specific video is about. But if you've just stumbled across this somehow and you're just wanting to learn about Betaflight Configurator, there's a link in the video description to a playlist with all the videos in it. And you should probably start with the first one. In the meantime, if you're here for the receiver tab, let's do it. And in the last video, we had just finished setting up the ports tab, and I said the receiver tab was going to be the next thing we do. And the reason we skipped from the ports tab, which was what was in the last video, past all this stuff to the receiver tab, is that getting the receiver working is one of the first things I do when I'm setting up a new build. Getting the stick movements of the controller to get into the flight controller. It's a pretty basic thing, and you really can't do a lot else when that's not working. So let's start here with the receiver mode. And almost everybody who's building a quadcopter today is going to select serial as their receiver type. Serial receivers have lower latency and more reliable, more precise communication about the stick movements. That's just what all the modern receivers do. Just for completeness sake, we'll go over the other options. A PWM receiver is going to be this older style of receiver with separate pins for individual channel outputs, one pin per channel. And those PWM receivers were originally used to drive servos. You would plug one servo into each channel and fly a plane with it. And then they were adapted for use with flight controllers. And then somebody came along and said, wait a minute, do we really need to have 8 different wires going between the receiver and the flight controller when we could just have one? And that brought us to PPM. So PPM signals are still analog signals, just like PWM signals, but all the channels are carried on a single wire instead of having a bunch of different wires, one for each channel. So this was just a movement towards what we have now, which is serial receivers, where we have a single wire going between the receiver and the flight controller, and it is a digital data stream that carries the channel positions. The main reason that we don't use PWM receivers anymore today is that they are much larger than is really required. When you have a great big airplane, that doesn't matter so much, but on a little mini quad, it does matter. And the analog PWM signal is not as precise. It's subject to jitter and calibration issues. So you would really only see this used if there was someone who just didn't have access to a modern digital receiver. Finally, we've got the SPI receiver, and an SPI-based receiver is going to be one where the receiver is built into the flight controller. And we mostly see that with flight controllers intended for tiny whoops. These very, very small quadcopters need to save as much weight as possible, and integrating the receiver into the flight controller can save a little bit of weight. But if you have installed your receiver in your quadcopter yourself, it's not going to be SPI-based. It's going to be serial-based, most likely. The actual last one of these, I said that SPI was the last, but actually there's one more, MSP. That one is, frankly, I've never seen it used, and I don't know a situation when it would be used. I think you would only use that if you were a developer, and so we're not going to say any more about it here. After selecting the receiver type, you're going to select the receiver protocol, or they call it serial receiver provider. And that's going to match whatever type of receiver you've installed, whether it's Crossfire. If it's FreeSky, then you're probably going to use S-Bus. And if you have a Spectrum receiver, you're going to choose the correct Spectrum protocol. There are actually several of them for whatever your receiver is outputting. There are some of these that are more obscure, like X-Bus, which I think is used with Jetty receivers. Some D and some H, which I think are used with Gropner receivers. And there should be Immersion RC Ghost here, but this board is running 429, not 430. So we don't see Immersion RC Ghost there, but on Betaflight 430, it will be there. So you're going to select the correct serial receiver mode and then the correct provider based on the receiver that you have installed. And when you've done that, if you turn on your controller, and if your receiver is bound to your controller, binding the receiver is a topic for another video, that's not a Betaflight topic. When you've done that, you should see that when you move the sticks on your controller, the channels right here move, and these are showing your channel positions. Let's talk a little bit more about that for a second. One thing that's confusing about the channel position indicators is that they go from a value of 1000 at the bottom to 2000, 2000-ish at the top. And that seems like a pretty arbitrary range of values. The reason for that goes all the way back to original receivers, which were designed to work with servos in airplanes. And without going too much into the history, servos had a range of movement of 1,000 to 2,000 microseconds. So you'll see channels in multi-rotors moving from 1,000 to 2,000 because that's just an old convention that's been carried forward. Don't let that confuse you. However, you may see that some of my channels, like this aux1, is at 2011. The endpoints are not always 1000 to 2000, and you may have to adjust the endpoints of the radio to get the channel to correctly go from 1000 to 2000. I've got separate videos about how to do that. We're not going to go into that in this video. That's something you do in your controller most of the time. So the main thing we use these readouts for is just verifying that our stick movements are correct. Like when I move my throttle stick, does the throttle channel move? When I move my yaw stick, does the yaw channel move? If I'm trying to do something fancy with my aux modes, does the channel move, the aux channel move like I intend it to, right? It's basically just seeing what channel movements the flight controller is seeing from your controller. And of course, if we power down the radio, we can see that these channels go to their failsafe positions. And the key indicator there is the throttle is at 885 and the other three main channels are at 1500. That means that we're not getting any input at all from our receiver. Next, we come to the RSSI ADC option. And this is going to be an option that almost everybody is going to leave off. The RSSI ADC option is involved with getting RSSI, or signal strength, into the flight controller. Knowing, it's like your cell phone. You have 5 bars, 4 bars, 3 bars, 2 bars, 1 bar, and then no bars. That's what RSSI is. And knowing the RSSI that your receiver is getting from your controller is useful because when the RSSI is too low, your quad will fail safe and fall out of the sky, and who knows what will happen. You may never see it again. So you want to know your RSSI if at all possible. The receiver knows the RSSI, and the receiver has to tell the flight controller the RSSI so that then you can see the RSSI like in your on-screen display in your goggles, right? That's what's going on here. We need to get the RSSI from the receiver into the flight controller. There are several ways to do that. One of the ways to do that is that the receiver may have an RSSI solder pad. So this is the instruction manual for the FreeSky XM Plus receiver. It has an RSSI solder pad, and if we look on the underside of an XM Plus receiver, right here is that little solder pad. So if you wanted to use the RSSI ADC feature, which you probably shouldn't, and I'll tell you why in a second, but if you were going to do that, you would solder a wire to this little tiny pad, and then you would go to the wiring diagram of your flight controller and you would find the RSSI pad, and you would solder that wire to the RSSI pad on your flight controller. Now, not every flight controller is going to have an RSSI pad, and if your flight controller didn't have one, you couldn't use this feature, but that's okay because, like I told you, you probably don't want to. There's a better way to do it. But if you do need to use analog RSSI, that's what the analog RSSI input, that would be how to do it. And then after soldering that wire, you would enable the RSSI ADC feature, and that would tell the flight controller that it needs to take its RSSI reading from the RSSI input pad, and then that would work. Now, here's why you usually want to leave this turned off. With modern protocols like Crossfire, Tracer, Ghost, Express LRS, generally, and even FreeSky F-Port, which is not actually that modern, there's a digital way, a serial way to communicate between the flight controller and the receiver. And so rather than using this, you have to solder a whole extra wire, lame. Rather than doing that, the receiver will just communicate the RSSI value to the flight controller in the background automatically via their digital. They're already talking about a lot of stuff. They just throw that in the bin. So generally you leave RSSI ADC off because if you enable it, it overrides the digital way, the better way of getting RSSI into the flight controller. You would only use this if the protocol that you were using didn't support communicating RSSI via telemetry. So for example, if you had an XM Plus receiver running S-Bus protocol, that doesn't support RSSI telemetry, and you would need to do this. But more modern ones do support it, so you don't need to do this. With me? Okay, let's keep going. Next, let's talk about the RSSI channel option, which is another way to get RSSI from the receiver into the flight controller. If you didn't have the ability or didn't want to use the RSSI ADC option, another way to do it would be to configure your receiver to communicate the RSSI value as an aux channel. So normally what happens is you flip a switch on your controller, and that causes an aux channel to move up and down that reflects the position of the switch. You can see here that aux 2 is moving up and down as I flip this switch back and forth. But that signal goes from the controller out the radio, out the antenna, to the receiver, and then from the receiver into the flight controller. So what some receiver manufacturers will do is they will have the receiver output the RSSI value as an aux channel. As the RSSI goes up, the aux channel will go higher and higher, closer to 2,000. As the RSSI goes down, it'll go lower and lower, closer to 1,000. And then what you can do is you can set your RSSI channel to be whichever aux channel your receiver is outputting the RSSI on. Then your flight controller will interpret that value as RSSI, and you can see the signal strength in your goggles or anywhere else you need to see it. So the key takeaway here is that if your receiver does this, like for example, the XM Plus can be flashed with a firmware that outputs RSSI on channel 16. You would need to flash that firmware to your XM Plus. Many FlySky receivers just automatically output RSSI on channel 16. And you'll look in here and you'll see aux 12 jumping up and down, and you'll be like, what's going on there? That's RSSI. Express LRS does the same thing. Express LRS outputs RSSI automatically on this aux channel. Crossfire, you can do it this way, but you actually have to go into the Crossfire system and configure it to do it. It doesn't do it by default. But lots of systems can do this. And if you don't have the ability to read RSSI directly from the telemetry, which many will, if you don't have that ability, this is an okay workaround. But if you do have the ability to get it from telemetry, then just set it to disabled. Incidentally, if you're not sure whether your RSSI is working, you can go to the Setup tab, and here is the RSSI readout that the flight controller is currently seeing. And if your system is not set up right, you'll either see an RSSI of 0%, which means it's not working, or sometimes you'll see an RSSI of like 50%, but then it'll just stay there and not move. And the key thing is, like, my RSSI is reading 78%, but if I move the radio over here closer to the quadcopter, it goes up to like 95%. It's pretty clear that that I'm getting like a real signal strength readout here. If that's working, then don't mess with this option or this option, because it's working automatically and you don't need these. These are for only when the automatic way isn't working. The channel map parameter controls the ordering of these first 4 channels: a roll, pitch, yaw, and throttle, which are the 4 main control axes of a multi-rotor. And confusingly, they are labeled with the airplane control surfaces: aileron, elevator, rudder, and throttle. So even though multi-rotors don't have control surfaces. It's a little confusing because here in the channel map, they are listed as AETR, which corresponds with these letters here, but we would probably think of them as roll, pitch, yaw, and throttle, so don't let that confuse you. If you find that when you move the sticks on your controller, the wrong channel moves, like you move the throttle stick, but here we see the roll channel move. If you find that that happens, you can rearrange those by rearranging these letters. And the letters, there are some presets here. Like if I choose default, no, how about spectrum? So the default spectrum preset is TAER. The default FreeSky preset is AETR, but you can actually reorder these. You can reorder them in whatever order you like to get the controls to work correctly. I would say it's better to just set up your radio to have the channels in the correct order, so that then it's just done and you don't have to change one of these every single time you build a new quadcopter. That's up to you. You can change these arbitrarily. Next, we come to the stick low threshold, stick center, and stick high threshold. And these values are used by the flight controller to tell whether the controller stick is down, centered, or raised all the way up. And the reason these are relevant is that there are stick commands that can be input to tell the flight controller to do certain things. For example, if you hold the stick center throttle, yaw left, and pitch forward all at the same time, that opens the on-screen display menu. There are other stick commands that can be used to do various things. But the most significant time that this is used is that the quadcopter will refuse to arm if the throttle is not all the way down. If the throttle is raised, it won't arm. And how does it know if the throttle is all the way down? The answer to that question is the stick low threshold. So you can see my stick low threshold is set to 1010 and my throttle is set to 1000. As long as my throttle is below this number, the flight controller will treat the stick as all the way down and will allow me to arm. And in fact, I can demonstrate that by going to the Setup tab, and if you look right here at the Arming Disable Flags, you'll see that as I raise the throttle, when it gets above 1010, I get the throttle warning, which indicates that we're not allowed to arm the quad because the throttle is not all the way down. The recommended way to set this value is to lower your throttle all the way down and look here at the throttle channel and see what value it's at. And then set the stick low threshold to about 10 more than that. So my throttle is at 1000, which is the correct endpoint. You want your endpoints to be 1000 to 2000. And so I'll set my stick low threshold to 1010. If your endpoints were not correct for some reason, and you weren't able to fix that for some reason, then you would just lower the throttle, and however low it goes, if it goes to 1087, you would set this to 1097, and then you would still be able to fly your quad. But you really do want your endpoints to be correct. And that's a controller-related thing that we're not going to go into in this video about Betaflight. So the stick high threshold works just like the stick low threshold, but it is used to determine when the stick is all the way up. And you certainly could set the stick high threshold by raising the stick all the way up, then subtract 10 from that value, and set the stick high threshold to that value. Bear in mind that all of your sticks are going to have their own endpoints. So I've been using throttle as the example, and it goes 1000 to 2000. You would also need to check yaw and pitch and roll. And if one of those values was way off and you didn't know how to correct it or weren't going to correct it, you would need to set the stick low and the stick high threshold based on like the worst case of any of your 4 main control channels. The stick center is used to tell when the sticks are centered. And this is important because when the sticks are centered, the quad will not rotate. So if you've got a quadcopter that as you're flying, it's just constantly going rolling to the right or rolling to the left or yawing slowly, it could be that your sticks are not centering correctly. The default is that the sticks will be centered when the channel is at a value of 1500, which is of course exactly halfway between the endpoints of 1000 and 2000. Now, if somehow you had a channel that wasn't centered, like I've just nudged the trim on my roll channel, so now it's off center. You might think, okay, well, I'm just going to go in and change that to 1490, and then my channel will correctly read as centered. Don't do that. One reason you shouldn't do that is that if you correct the roll channel that way, now your pitch, your yaw, and your throttle channel won't center correctly. So you really want to adjust the controls in your transmitter to make sure that all the channels center at the correct value of 1500. So then what is this value even for? There's like one kind of receiver out there that for some reason centers the channels at 1520. If you had that kind of receiver and like all your channels were centering at 1520, you could change the stick center and the quad would still fly basically right. But generally you just want to leave this at 1500 and adjust your controller endpoints and centers. RC deadband. Do you see how right here, if we look at my roll, pitch, and yaw channels, they are rock solid, 1500. They're not moving. We're not seeing little wiggles and jiggles here. And that's because I have really high quality gimbals in my radio, I guess. Or maybe I'm just lucky. On some radios, especially less expensive radios with cheaper gimbals, you will get a tiny amount of wiggle and jitter here. And when you look down there, you'll see that. And that mostly doesn't matter while you're flying. As you're sort of moving the sticks and flying the quad, a tiny amount of jitter is probably not noticeable. But when you center the stick, the quad is supposed to be rock solid, not moving, not drifting. And even a tiny amount of jitter can cause it to move just a tiny bit. And the difference between not moving and any movement can be really noticeable. So if you have a tiny amount of jitter here, you can add deadband. And what that will do is it'll add a small window around the center stick, where whenever the stick is within that window, it's just treated as if it was centered. So what you would do is you would look at how much the stick is wiggling. If it was wiggling from like 1498 to 1502, you would add, do you add 2 or do you add 4? It doesn't say. I'm never sure whether deadband is the total size of the window or whether it is how far plus and minus. So I guess I would add 4 to the deadband, and that would mean that that little bit of jitter around the center would be canceled out. A yaw deadband is deadband for the yaw channel. RC deadband is deadband for the pitch and roll channel. They're broken out separately because sometimes yaw is more noticeable. And then 3D throttle deadband, you're only going to care about this if you're flying 3D multirotors. 3D means that you can flip the multirotor upside down, you can reverse the motors, and then it can fly upside down. This is pretty obscure. Not many people do it. It relates to the deadband when you transition from right side up to upside down. Well, okay, just a couple more things. At the bottom of the screen, there is a readout here that shows the channel positions over time. That may be more useful to you in some way than there it is. At the top of the screen, there is a preview, and as you move the sticks on your controller, that little 3D model of the quadcopter will move exactly as the real quadcopter would move. And the key thing here is that this takes into account your rates. And rates is something we're going to talk about later in the series. But as you move the sticks, the speed with which that quadcopter is moving is the speed at which your real quadcopter would move. So you can try out changing your rates and look at how this moves as you move the sticks. The other thing is that if that doesn't move at all, but you see the channels moving, it indicates that your rates are set very low. And that would be something you'd want to fix before you go and fly. Finally, we've got the RC smoothing section. And there's a bunch of different parameters here that we're not going to talk about for 2 reasons. Number one, RC smoothing is fairly sophisticated, and especially in a beginner video like this, there is no reason to tell you anything about it. You just should not be messing with it because you don't know what effects they're going to have. But second of all, there are Betaflight presets. So if we go to the presets tab here, and if we choose categories, RC link. There are RC link presets for whatever RC link you're using. In other words, if you have Immersion RC Ghost, there are Ghost presets. If you have Express LRS, there are Express LRS presets. There are presets for Crossfire and so on. And if you want to get just a little better performance out of your control link, not better performance in terms of longer range, but like smoother stick inputs with less latency, you can choose the presets that's correct for your quadcopter. So I've got a Crossfire receiver in this quad, so I would just type Crossfire here in the search box. I've got 2 choices, one for Crossfire 50 Hertz and one for 150 Hertz, depending on what Crossfire mode I'm using. So I'll choose Crossfire 150 Hertz. Here, I have to review the list of options. Let's see, I'm flying freestyle, so I'll choose freestyle here. What does that do? I don't know. That's the beauty of presets. You just pick the preset that's right for you. You choose pick, and then I actually am not going to proceed because this quadcopter doesn't have Betaflight 4.3 on it, and this preset was made for 4.3, but I would hit agree, and then I would hit save and reboot, and it would apply those presets. My point is this. Instead of thinking a lot about RC smoothing and what do all these things do, just pick a preset that matches your control link and get on with your life. Unless you really want to dive super deep and learn about how to tune all these things. Once you've got your receiver working, the next thing to do is to set up your aux modes. And that will be the next video in this series. And I'll put a card on screen so you can get to that as easily as possible. There's also a link to the whole playlist down in the video description, as well as a couple reference videos to help you do things like set your channel endpoint and so forth. Stuff that I talked about, but I didn't dive into as much detail on. I'll see you there.